Thanks very much for having me. My name is Brian Gratwicke. I am the amphibian conservation biologist at the Smithsonian Conservation Biology Institute. 1989 was the last year that the golden toad of Costa Rica was seen in the wild. It is also the last year when scientists coined the term enigmatic amphibian declines to describe mysterious disappearances of amphibians from all over the world, including in national parks. Amphibian biologists investigated many different causes of the declines, but it wasn't until a decade later that a smoking gun was found. Researchers in Costa Rica, Australia, and the National Zoo independently discovered a new skin pathogen associated with the deaths of frogs and called that disease chytridiomycosis. The amphibian chytrid fungus has now been linked to the declines and extinctions of about 100 species of amphibians. In Panama alone, 9 species have disappeared from chytrid-related declines, including this Cherokee harlequin frog, which was last seen alive in 1996 on the Costa Rican border with Panama. We have now recommended to the IUCN that they officially list it as extinct. Herpetologists were concerned that the iconic Panamanian golden frog might also disappear, and they created ex situ assurance colonies of this incredible animal just in case their predictions came true in the year 2000. And then just 6 years later, in 2006, the amphibian chytrid fungus arrived in El Valle de Anton, which is the home of the Panamanian golden frog. And there were dramatic amphibian declines, resulting in the loss of 90% of the individual frogs and about half of the species in a community in just 5 months. The last individual Panamanian golden frog was seen in the wild in 2009. Fortunately, the captive breeding colonies were a success, and now 2,000 of these frogs exist in captivity, including at the National Zoo. This encouraged zoos and aquariums all around the world to try and expand this concept and to build a global amphibian ark. In 2008, we formed a consortium of zoos and aquariums, including the Houston Zoo, the Cheyenne Mountain Zoo, Zoo New England, Defenders of Wildlife, and the Smithsonian. And we teamed together to create the Panama Amphibian Rescue and Conservation Project. Our mission is to build capacity in Panama to house and care for the most endangered species and to search for a cure for the disease that's been wiping them out. So Maersk Line donated 7 refrigerated shipping containers to us, the same kind that ferry ice cream and frozen strawberries all around the world, including up and down the Panama Canal right next door to our facility. And we modified these shipping containers to breed critically endangered frogs and keep the chytrid fungus out in a biosecure environment. We considered all 214 species of amphibians that live in Panama and determined that our chances of actually avoiding an extinction were highest for just 12 priority species that we now care for in these 7 shipping containers. So the zoo research and conservation community over the last 20 years has learned a lot about managing small captive populations. And this has really allowed us to build on the successes of previous efforts like black-footed ferrets and golden lion tamarins to use these incredible tools that have been developed, like stud books and assisted reproduction techniques like Mary was telling us about, and frozen sperm biorepositories to manage our small populations so that we can prevent unintended bottlenecks, genetic bottlenecks from captivity. And if all goes well, we get baby frogs. And to riff off Elder Leopold, this ensures that we have the necessary cogs and wheels so that we can begin tinkering to get these animals back in the wild where they belong. This week, we announced our most recent cause to celebrate. This is the first ever baby captive-produced vanishing robber frog in captivity. And it's called the vanishing robber frog because it was described pretty recently from a park where it had already disappeared. And furthermore, the 8 most closely related species to this vanishing robber frog are already thought to be extinct. So this is a cause for celebration. And we've spent a lot of time really trying to get a handle on ways to fight the disease. And in the last few years, microbiologists have significantly advanced our capacity to observe microbes using new molecular tools without having to culture the bacteria on frog skin first. And when we looked at the microbiomes of Panamanian golden frogs, we found that a few special captive-bred Panamanian golden frogs were able to become infected with the chytrid fungus and totally clear the chytrid infection. And they all had a very unique skin microbiome. And the key distinguishing bacteria on the survivors were not found on the frogs that died. So over the last several years, we've spent a lot of time isolating antifungal bacteria from frogs and then trying to add them to experimental groups of frogs and then expose them to the chytrid fungus in an attempt to develop a probiotic cure. And it hasn't really worked very well. So we said, we're going to be cleverer here, and we're going to take the most common skin bacterium found on all Panamanian golden frogs in captivity. We managed to isolate that and culture it, and then we genetically modified it to produce violacine, which is a very strong antifungal compound. And we successfully did all of this and put it back on the golden frog skin, but unfortunately it seems like frog skin microbiomes don't like to follow our instructions, and they had no protective effect. In addition to the microbial defenses, host immune responses are also associated with different disease outcomes. New transcriptomic tools allow us to compare the genes that are most active in frogs that resist chytrid infections and to compare them with the transcriptomes of frogs that die. We even looked at the transcriptomes of those same surviving golden frogs to see if they had any special genes, but it turns out that because we took our transcriptome samples after they had cleared infection, they'd already returned to their baseline genetic levels. So what we're now doing, Alyssa's in the room here, she's the one who's doing that, she's the culprit, is trying to develop a tool that will allow us to just swab the same individual or take a skin biopsy from the same individual during the course of an infection, so we can actually look and see which genes are being turned on and off and see how that relates to a specific gene outcome, a specific disease outcome. Now, studying diseases in wild frog populations is very challenging. Most of the frogs in any community are just too rare to get sufficient sample sizes. Studying multi-species epidemics is always very much a case of now you see them, and now you don't see anything, and you're just left with a frustrated researcher in the field with no frogs to study. So our success with captive breeding has now allowed us to produce enough surplus frogs that we can begin our first experimental releases of large numbers of Lamosa harlequin frogs that we'll be doing this spring. And we will track these using ultra-small radio transmitters that weigh just 0.3 grams. And for the first time, we'll be able to observe the fate of a discrete cohort of a known number of frogs of a single species and try and get more detailed insight into disease dynamics. But one of the most rewarding aspects of this work has been the tremendous outpouring of public support from zoos, aquaria, donors, foundation, and the people of Panama. Every year we help to coordinate a Golden Frog Festival, attended by about 3,000 people, and there's an annual parade where all the kids dress up like golden frogs and march down the streets of El Valle de Anton and take pride in their national symbol. Our project is ambitious, and it's one of the largest amphibian conservation efforts of its kind. Because we were willing to tackle the problem at a national scale, 12 incredible amphibian species now have a very different future. While our efforts feel Herculean, they're just a drop in the bucket when placed in the context of the global need. That is why the Amphibian Survival Alliance has been created, and that's going to help us to build the capacity and the partnerships we need to scale up our actions to have an effect at a global scale. It's easy to be optimistic about conservation stories that have already achieved their goals. Those congratulations are hard-earned. But a vision for the future in the face of tremendous uncertainty is most needed at earliest stages in the project cycle. And I'm optimistic about the future of amphibians because I can sense a new momentum, building a virtuous circle. Each new win and breakthrough and discovery inspires new questions, it motivates new actions, better husbandry, new funding, and it attracts new talented colleagues to help try and solve the problems. And on that note, I'd like to thank all of our employees, collaborators, and partners for helping us to realize the vision to preserve Panama's rich biodiversity heritage.
¡Rescatando los anfibios!